Okay, we're going to handle this in several different ways, but we're going to cover different materials and the different components of different types of walls today. Keep in mind that as we go through this, most of the time we are dealing with a pretty common wall type throughout a region based on what that region's environment really demands and also the economics of what's available for us to build. Because certainly if we're building in the Northwest, we're using lumber. Why? We got a lot of it. If you're in the Southwest, are you using lumber? Yeah, but not as much. You're using some other materials like maybe some adobe or sand or they use a lot of different materials depending on your location and availability of materials and what we need the structure to accomplish. Okay. Because remember, what we're doing here is trying to make sure that the occupant's needs are met. Okay. Now, as we look at a wall, any wall, you have to kind of quantify a little bit who's building this wall if you are going to describe it on a drawing. Does anybody know who in our area, who builds the walls for a house? What do we call those people, our construction folks?
Framers?
We call them a framer. They in essence, build our walls. Now, they may not build all the wall types, but they build the majority of the walls on a residential structure. About the only ones they won't build are the concrete ones. Okay, because generally that is done by some foundation worker who does concrete walls. Okay. But for the most part, it's a framer. Now, one of our mandates when we draft is we always show the object in the finished condition, right? I don't know if you remember this. Back in 131 through 135, we talked about this and said, always show the part in the finished condition. And around the 90s, we quit telling these craftsmen how to build stuff, right? Remember the abbreviations? We now use depth, and I don't say drill this or ream this because I'm not the construction specialist, right? We leave that up to the craftsman involved. With walls, we don't always draw them in the finished condition based on who's building it, and typically this is the framer. Okay. So you got to know which wall you're dealing with and when the framers show up. When we're looking at a floor plan, like is shown on 355, remember this is a full section taken approximately 4 feet off the ground. Okay. You can see the walls on this drawing where they're shaded in deep here. Okay. Because remember, this is a full section. Okay. So a lot of people will use some hatching to denote that this is a section. Just a little caveat, and I'll say this later, if you're going to hatch your walls, I don't have a problem with that, but don't do it now. You're in the process of developing where these walls go, and if you're going to be moving them and stuff, you got hatching in there now, you're going to make everything more complicated, right? Because now you got to move hatches with it and everything else. So leave that off for now. Now, when you're drawing an interior wall, okay, this top figure right here, it kind of compares the exterior versus an interior. But when you're drawing those, you got to know where you're at. So if I'm doing an exterior like they show here with a 2x4 stud, and we do build these in our area, where we do an exterior wall with a 2x4 stud. We then have to come in and do sheathing and siding on the exterior of this wall. Okay. Typically, if you are doing an exterior wall, you never draw it with the outside cladding. Okay. Whenever you're doing an exterior wall, do not draw it with the exterior cladding on it. Why? When the framers show up, they're sitting there with a platform. Okay, maybe not even that. It's probably a hole in the ground with concrete on it, and they got to build the floor before they build the walls. But in essence, where are they going to hook a tape on? They're going to hook it on the edge of the floor platform to measure where to put all these walls at. Well, this exterior cladding does not match up with where the floor is. It's outside of it. Okay, so therefore, when we're doing exterior walls, we draw them without anything on the outside. Now, that's okay, because when they go to sheathe the wall or put siding on it or put brick on it, do they really need dimensional information on where that stuff goes? No, they've got a wall sitting there. They're not moving the wall. They're going to brick on it, or they're going to stucco it wherever the wall is sitting. So that's the one thing. Exterior walls, do not show them with exterior cladding. Now you do show them with the interior cladding. I was going to go into codes today. I'm not going to get there. I forgot about Thomas coming in, and we need some time to draw, so I'm not going to take up 2 hours of lecture time. So we're just going to deal with this subject. You show the interior portion. Typically, this is 1/2-inch drywall in our environment. So depending on if I'm doing a 2x4 like this one, or a 2x6 by this one, that tells me how wide to draw the wall. If it's an exterior wall, no exterior cladding, show the sheetrock on the inside. Yes?
Question back to the outside siding. So you don't specify what it is, but you still put it on their siding?
We will show this exterior cladding in other views. Section views, elevations, these types of
So
things.
I'm just thinking it's wrong, you wouldn't even put siding on anything in the dimension there. So you would take out.
No, they're showing you how the wall's built here.
Oh,
Okay, I'm telling you how to draw it on your floor
Okay.
plan. Okay,
Okay.
and maybe I never made that clear
Okay,
at the
that's
start.
okay.
Okay. So I told you to draw exterior walls at 6 inches.
Okay.
Okay. Why is that? Because we primarily do 2x6 walls. Okay. Well, how wide is a 2x6 stud? I've got one sitting right here. Typically with what we call nominal lumber. By nominal lumber, I mean a 2x2 or a European stud. Okay. 2x4, we don't use much 2x2s around here. 2x4, 2x6, 2x8, 2x10, 2x12. Those are my nominal lumber sizes. You've probably all heard those terms. Subtract a 1/2 inch from the dimension and you have the actual size of this. So this is a 2x6. So if I'm going to subtract a 1/2 inch, what size is it really? It's 1.5 inches by 5.5. Now, we used to make them true size. But due to the fact that we've lost a lot of old growth forests and stuff, now we don't, because this is more than structurally adequate to hold up a residential structure. The reason we use 2x6 in our area, right here, versus 2x4 for the most part, is not because of strength. Okay. This is a 2x4. What size is this one?
3.5 inches.
By?
1.5.
1.5 by 3.5. 2x4, subtract a 1/2 inch. This guy right here is more than strong enough to hold up any residential structure. By the way, wood is the strongest material we have by weight. You know, it's stronger than steel when you start thinking about the weight of it. And this stuff's extremely strong. In fact, I can take one 2x4, 8 foot long, and Gabe, I could take your little Mini Cooper and set it on top of this and it will hold it up. They'll hold up well over 1,000 pounds, each one. Very, very strong. The way they grow, you know there's, what do you call those little rings in here? Grain, right? Wood grain. If you look at a piece of wood under a microscope, it's really a pretty fascinating product. So if I've got a piece of wood and I've got grain in it, as the tree grows, it has millions of little fibers that feed in between these layers, back and forth. And that's really where your strength comes from. Now, it comes from there if your forces are working parallel to the grain. If we work perpendicular to that grain, that strength is not there. So that's one of the reasons we take wood and we cut it. You'll look at every one of these, you're going to see the end grain and the end of them because we're cutting parallel with that grain. That keeps the strength. If we cut them this way, well, we'd have to have a huge tree to get an 8-footer, but you would be cutting parallel to that grain and its strength would be greatly reduced. Really pretty amazing material. Yes, Ed?
Is that why OSB has a strength axis like that? Because they put it all together in the same...
Yeah, they
The
call
same-
out a strength axis on OSB, but they usually always call it in the 8-foot length, and in today's world, really, it doesn't have a strength axis. It is equally strong both ways due to the way they make it.
Right.
It used to be they layered all the chips the same way, and those are the ones that have the strength axis shown on them.
Right.
If you don't have it on a piece of OSB, then what they did is they laid a layer of chips this way, and then the next layer, they laid them the other way, kind of like a piece of plywood. You know, plywood is wood veneer. And so they do sheets, but they do a sheet of grain, one this way, one the other way, so it has both strength axes. But there's some of that. If you've never measured one of these, I'm gonna pass them around. Take a tape or your scale out and measure these, because you gotta know that these sizes are here. And I think there's nothing to drive you that more home than just sitting here and holding one and measuring it. What size is a 2 by 12? Okay, supposed to be. It's not always. That's one that gets off quite a bit, but it is supposed to be when you purchase it. Okay. 2 by 10 would then be 1.5 by 9.5, and so on through the deal. Okay.
I know those.
Okay, I'll pass these around. You should measure the sizes. Now, these have been sitting here for a long time. In fact, I brought those in probably 15 years ago. So they might have shrunk a little bit more as moisture has gone out of them. They might be a hair less. Okay, so bottom line, exterior walls. Show the stud, 5.5 inches, and the 1/2 inch sheetrock. That's why I said draw these exterior walls at 6 inches. If you're drawing an interior wall, okay, the framers are going to lay this out based on the center of the wall, like these interiors down here. So depending on if you're doing a 2 by 6 or a 2 by 4, you show it in its finished condition. Most of our interior walls are 2 by 4, right here. So you got 3.5 inches for the stud. You have 1/2 inch sheetrock on both sides. Hence, I said, draw your interior walls at 4.5 inches. If you're ever working off of a hand-drawn set, you're going to see the interior walls drawn at 4 inches. And that's strictly because they measure off of a scale. And they're not going to go to a 1/2 inch. Okay? They're just going to draw it at 4. So it's for convenience. In the computer, we draw them exact. Do we have 2 by 6 interior walls? Do we? Does anybody know?
Yes.
Yes.
Okay. You have some, Declan, why would we do a 2 by 6 exterior wall if a 2 by 4 has the strength? Insulation, that's one of the reasons. There's one other, really, in my mind. Insulation, by the way, if it's an interior wall, we're really not worried about thermal insulation. Usually it's a sound barrier. Okay, so we're insulating it to kill sound. Would be the other reason.
Cost?
What's that?
Cost?
No, it's not.
No, it's more expensive to go 2 by 6. Because really you're buying material, so the 2 by 4 is cheaper.
Second story?
Most second story homes have 2 by 6 walls in the lower floor. Think bathrooms.
Or plumbing.
Shoot, or whatever.
We need plumbing and walls.
What else do you call it?
That's a good technical term, I like that one. Hoop shoot. Is that on video?
Oh my God,
It is.
There you go.
This is Lisa Mary, she lives
I gave you
at...
one.
No, we do need that. You need plumbing walls. Now, that only occurs in the floor below a bathroom. All right. And the reason is we need to have 3-inch plumbing at a minimum for a toilet. So when we bring it through, if you got 3-inch plumbing, that's the interior diameter of that pipe. It's actually 3 5/8 or so. It doesn't fit in a 2 by 4 wall. So we go 2 by 6. And it's strictly to carry the pipe. Okay, that's the only other reason we really do it in our area. Okay. So these are wood walls. Now, when we put these configurations together, there's a couple pictures in your text later on, but I kind of think maybe for the initial one, I just draw you a sketch. Okay. When we're doing a wall. This is the way it's actually built. So now, before I go into the components of it, notice how this is built, where I have individual members, some stacked horizontally, some stacked vertically. Okay. How is this shown on a floor plan, like on 355? It's shown as a solid surface. Okay. Now we're making this section 4 feet off the floor, so we're cutting through a piece of wood here, piece of wood here, piece of wood here. Is it really solid at 4 feet above? No, it's not. But we represent it as a solid piece. Okay? So don't draw the individual studs. Just a couple lines. We probably won't hatch them. Not many people hatch in the residential market. This is more of a commercial or architectural feature. You just have two object lines representing the edge of your finished surface. So again, we don't draw the drywall in there. We just add it as part of the wall component. Okay, so we're not going to draw 3.5 inches, another little line 1/2 inch off, because we're not going to see it at the scale we print anyway. So when we do this, so here's a typical wall that's done in our industry. So you have 3 real components here. You have what we call a sole plate. That's its bottom piece. It's also called a bottom plate. I think the technical word for it is a sole plate. That kind of means the bottom, right? The sole of your shoe. So this is your bottom piece. It's laid in a horizontal fashion. On top of that, we put what we call studs. Okay? In our area, those studs will be 2x4 or 2x6 as a general rule. On top of that, we have our top plates. Most of the time, we have 2 top plates. It's really only required on bearing walls to have 2 top plates. And even then, you don't have to have 2. Now keep in mind, why would we put 2 top plates up here? It's for structure reasons. If I have 1 top plate, but I put a truss on here that's carrying weight and pushing down, if that truss is right above a stud, I only need 1 top plate because the weight is transferred directly down through it. If I have, now that means that you're laying your trusses out based on your wall spacing because they've got to be right above it. Most people do not want to take the time for that. It's cheaper to put 2 top plates here, and that way I can put my bearing surfaces here anywhere I want. I now have 3 inches of wood that will carry that weight to the stud, so it acts as a mini beam. And that's really kind of the reason we use 2 top plates. It's more to convenience us when we're putting weight on them. But you don't have to. For our area, you're going to see probably 99% of all structures built with 2 top plates. So, bottom plate, studs, double top plate. That gives you a height depending on what you're doing. Now, when I go ahead and list the height of this, I put it over here. Notice I've got 8 foot 1 1/8 or 9 foot 1 1/8. These are kind of our standard wall heights for wood walls. In essence, we buy studs that fall into these categories. So if I take, let's say I'm going to do an 8 foot wall. What I do is I buy a stud that has a length of 92 5/8. And these are pre-cut at the manufacturer. Well, let's add up the height. I've got a horizontal stud sitting here, or a bottom plate. This is the 1.5 inches, by the way. Juan, do you got those pieces of wood on you? They're right up here. Okay, so the bottom plate and top plates, they're not sitting like this. They're sitting flat. So if they match up with the one sitting on top of it. Okay, so they're sitting in this configuration. So what's this dimension right here? Okay, so that's 1.5 right here. I have 2 of these in the top plate configuration right here. That's 3 inches. Now, add all those up and let's see how many feet that is. Somebody got a calculator? 92, 95, 96. That is 97.125 if I did my math correctly. What's that? Is that correct?
Yeah, you're right.
Okay. Well, 8 foot is what?
96.
Okay, 8 foot is equal to 96 inches, so if I take 96 and subtract that, I've got 1.125 inches left. Why would we build this wall at this weird configuration? Well, it is to accommodate our interior space. We want an 8-foot clear. Typically on a ceiling, I use 5/8 sheetrock. So up here, I've got 5/8 sheetrock. On the bottom, we have carpet, wood, tile. Most of those floorings are around a 1/2 inch. Okay, so I've got a 1/2 inch down here. Well, if you take a 1/2 inch and 5/8, that's equal to 1 inch and 1/8. So if I do an 8-foot wall, I got 8 foot clear once I'm in my finished space. 9-foot wall does the exact same thing. I'll have 9 foot clear when I'm done, approximately, depending on what I put on the floor. So that's why we have these weird sizes right here of an actually built wall. The spacing of our studs, you can go 4 different real spacings that we use here. We use 12 inches on center. We use 19.2 inches on center. You use 16 or 24. Why would we have all these different spacings? It really kind of depends. The 12 and 19.2 work better for joists. They match up with 4. All of those numbers, I should have said this first, all of those numbers divide into 4 feet evenly, so that I can attach drywall, 4-foot wide sheets, OSB, 4-foot wide sheets, and I put them on there and I don't have to cut them. Okay, that's what that spacing is there for.
What's Valiant?
What's that?
Valiant?
Balloon. Balloon. That's part of my end.
It's not, oh, I did, okay.
Are you critiquing my lettering?
Well, I didn't know something I didn't know about.
It's either not
Of course I
letters.
thought Melissa, no, I didn't say Melissa's Valley on.
That's what happens when an engineer tries to do architectural text. It just doesn't work.
I didn't know there was something I'm supposed to know.
For our area, we mostly use 16 or 24 inch spacing for walls. The 16 inch spacing is the preferred. And I really think this is driven more from performance than anything else. I don't have a real solid answer on why we use 16 over 24. It's actually a worse performing wall. I think people like it because when you go to the 24 inch spacing, your drywall has a tendency to vibrate and it sounds like you're hollow. You can hear the reverb of it when you walk across the floor.
It's also better for any pictures and hard things to find it.
Yeah, but the 24, what we call balloon framing, or energy efficient framing, is a better efficient wall because the studs transmit the thermal energy through the wall. The insulation in between stops it better. So if I have less wood, it's a better acting wall, at least for thermal efficiency. For the most part, we go 16 inches. What that means is I measure from the center of this guy to the center of here, there's 16 inches. There's 16 inches to the next one, 16 to the next one, blah, blah, blah. Yes?
If you're really watching your budget, would it be cheaper? I mean, would you recommend it in 24?
It's a lot cheaper.
Does it make?
It is quite a bit cheaper, because you gotta figure in every 4 feet.
Yeah.
This one requires 2 studs, this one requires 3.
Do you
So
have a-
every 4 feet, you're saving you the cost of 1 board.
Do you have a percentage would typical from a house that, be selling?
You could run it out, that's approximately 1/3 of the cost.
Which is how Corey Barton and Hubble and stuff get away with things sometimes. A lot of times they'll frame an entire house on 24s and 4-inch walls instead of 6.
Okay.
Think of the mind, on our house, we're 48 by, what, 36 primarily? If you add that up, that's 120, 130, that's approximately 200 linear feet. So you can figure out real quick, you're saving a stud every 4 feet of that, we're saving about 50 studs. And the cost of it, if they add up. So, but, will you like the performance of it? To be honest with you, I don't think many people like the 24. I've talked to a lot of people who live in these houses and they don't really like it.
Like I said, you can't find one.
Well, I think it's more because of the sound. Certainly, we do have hanging issues, stuff like that.
I
Okay, so anyway, that's really what you're gonna see out there, is those types. If you wish, I'm just gonna real quickly go here. If you're not familiar with this, a good thing to do is just type in how to frame a 2x4 wall, and there's all kinds of videos on it, and they'll show you all of the different components. Now, we're talking just the basics. We'll come back and talk, like on this, where we talk window and door framing. We'll cover this when we do our windows and doors, which will be in a couple days, and how we frame those openings in. For the most part, we're just looking at constant wall widths here. And I think you'll find this is pretty common through here. Let me just go find one here. All I did was type in wood wall framing. Okay, so here's one right here that shows a house kind of halfway. Structure's pretty much done, and we're ready for exterior cladding and stuff. You can see these studs down through here. This one looks like it's 16 inches on center. 2x6 exterior, just like we would do here. There is a video that will show you how these walls are built. I'm sure you can find one of those. If you've never built one, I'd recommend you take 5 minutes and watch this. 5 minutes and 56 seconds. There will be a matchup on how we dimension to how these people put them together. We're going to dimension to help them. Okay, that's what we're going to do. All right, now besides wood, why would we use wood? Think about